All right, so we want to do 5.2, number 28, which consists of a statement about a population. So, hold up, what? Okay. I gotta wait for you, Gabe? Okay, we'll wait. We'll all wait. Okay, I'm done waiting. We have a population that grows from 11,000 to 13,000 in 3 years. Cool? And then I'm supposed to assume the growth rate is exponential, find the annual growth rate, the continuous growth rate, and then answer why are those different. Okay? Okay, so what's the annual growth rate? How do I do that?
Growth rate per year.
Okay, so growth rate per year. So I'm saying, all right, so the 13,000, right, is the 11,000 times something something. What's the something something?
11,000 over 3 years is only 3 years.
Yeah, there's 3 years, right? So we're compounding 3 times, and we're doing 1 plus whatever the growth rate is. You guys cool with that? No?
Yeah,
No.
I do. It's like I kind of forgot it already. It's like feels like it's been forever.
Yeah, that's okay. I'm going to keep reminding you, and eventually it'll stick in there for at least a couple of minutes.
Like for tests, like a couple
Yeah,
days.
like for the test. And then later when you need this, learning it will be faster.
Mm-hmm.
Really all I can ask is that you guys will learn faster the next time.
Okay.
So how do you solve this then?
So you divide 13,000 by 11,000?
Okay. So you get 13 divided by 11 is 1 plus r cubed.
And you take the cube off.
Then you take the cube off, how? Radicalize.
Radicalize.
Okay, so we cube root 13 over 11, and that's supposed to be 1 plus r then, right? So this was, did I need a plus or minus?
No, it's a cube, so no.
Good, perfect. No, it's a cube, so no.
Oh.
Good answer. Okay, so once I'm here, what do I do? Subtract 1. That's where you got to there and got lost. All right, subtract 1. So you get r is the cube root of 13 elevenths minus 1. Make sure you don't accidentally dork yourself and put the minus 1 in the cube root. It's not supposed to be in there. This is your answer. However, if I'm going to compare this with some other growth rate, I probably need an approximation for this. So, somebody nail that down.
0.0573.
0.0573.
And then plug it in?
Okay, so that's like 5.7%, give or take. Okay, so that's my annual growth rate, right? All right, so how is this process going to be different for the, wow, that video is awful. How is that different for the continuous growth rate? Like,
You have to convert it. Because you have,
No, we just do this.
yeah,
We use the same numbers with the other formula.
yeah, so this here, right, was me doing 1 plus r 3 times. And continuous is
All time.
compounded all times, right? So to do that, I have to go all the way back here and say, all right, we're going to apply the continuous model instead. So we're going to dump all of this. I'm going to keep that here. That was my annual, right? So I'm going to rewrite 13 is 11,000. 13,000 is 11,000 what? E to the, and then this would be a KT, right? Or RT or something. So the R is the thing I don't know. What's the time?
3.
3. You guys see that? Okay, so now what do I do?
Same thing.
Solve it, same thing.
Except it's a natural language or something.
Divide by 11,000, so you get 13 over 11 is e to the 3r. And then you need the r off, right? So you need to natural log both sides. So you get the natural log of 13 over 11 is 3r, right? And then you divide by 3. How about we multiply by a third, because we're adults.
Didn't do that over there.
So we have 1/3 log of 13 over 11 is r, right? So somebody give me an approximation for r.
0.056.
0.056 something? 5?
565.
Okay,
Oh, that's about the same.
so that's about the same, right? But it isn't quite the same. So that's me thinking this is approximately 5 point,
7 if you keep it. approximate.
yeah, I guess if I round. Let's call it 5.6% just so they're,
Well, you're already
right, they are a little bit different at least, right? So up to rounding they're the same, but what the, like, where's that little difference coming from?
Forever, instead of doing it 3 times, you're doing it a bunch of times.
Yeah, this is happening all the time, right? So a slightly slower rate that compounds all the time is a little bit faster than that same rate if it compounded only 3 times. So it needs a little bigger rate. You guys see that? So which model is they just said a population, right?
Continuous would be better.
So which model is most appropriate?
The continuous.
It depends. Yeah, do the creatures have, like this population, right? If they're bacteria, continual is appropriate. Right? They just kind of multiply or however the hell bacteria work all the time. But if they have some kind of set defined breeding cycle and they're pretty safe the rest of the time, then you're really looking at something like that. You guys see that? Okay, so that's sort of the answer to C, like why are they different? Do you guys have any questions on that?